Good.
All right. So what we're going to do today is we're going to look at load balancers. There's a lot of topics to cover and still a long way to go. So I think we need to move a little fast. But again, each topic is as its own. Yesterday itself, S3 we went through pretty much quite a lot. Today we're going to talk about elastic load balancers or ELB. Before I start, let me just ask, how many of you are familiar with any type of load balancers? Anybody here worked on load balancers like F5 or NetScaler or Cisco CSS, any of those? Anybody is familiar with the load balancers? What is load balancer means?
I don't have any experience on any sort of load balancer, but just from the title, I think it's just about managing the input and output on all the VMs or something like that. I don't know.
Okay. Anybody else? There are quite some people in the class, guys, you got to speak, okay? What is a load balancer?
I don't have an experience with load balancer, but it's it regulates the traffic from if it's the load is on, if the CPU reaches 80%, then it might shift to the other server, and it balances the load equally among all the servers or something like that.
Okay.
And the traffic is high.
Any other?
In a multiple node environment, when the load in up in one node, it goes to the second node, and that way the load is being balanced.
Okay.
High availability, zero downtime, etc.
All right. Okay, that's correct. All these things that you mentioned are kind of fit inside this load balancing.
Cash on the
Karthik, can you please mute? All right. So load balancing, it's meant for high availability, better service. A lot of advantages of having load balancers. For example, Google.com. We all go to Google. Google, is it Google running from one server? No, Google.com may be running from hundreds of servers. And at one point of time, you may be hitting one or the other server, but they all serve the same thing. So when you talk about high availability, there is a term which normally people say is called as cluster. Microsoft has a clustering service. Oracle, you can make clusters. There are Veritas clusters. There are so many different type of application level clusters, operating system level clusters. There are different ways you can make a cluster for. It's all done for high availability and better serviceability and things like that. So Microsoft clustering, for example, SQL Server, Exchange Server, your home directory file servers, you cannot have those services going down. If you're working in a financial company and all, you know how important is these clusters. So Microsoft has a clustering service called as Microsoft Clustering Service, MSCS cluster, or nowadays it is called as a failover cluster. So what that means is there will be multiple nodes. I'm just drawing a 2-node cluster. So these are 2 Windows servers. They will be shared with a hard drive. And this is where probably your database is sitting. So there will be a SQL server running here. There will be a SQL server running here. But at a time, there is only one SQL server will be responding to the queries or whatever it is, all the database. So it can be configured as an active, passive cluster. Now this cluster will have a general name, or normally that is called as a VIP or virtual IP address, something like 10.10. 10.10.50. So when your application servers and they want to communicate to the database, they basically communicate to this VIP. And when it comes, whichever is the active node, that active node will take the calls and then it will pass it to the database. If one of the node fails, Microsoft clustering, there is a term called failover. Failover. It will fail over. That means now this 50 will be coming to here and this will become the active node and then this node will start servicing your database. So that flip over or the failover is probably in less than 1 or 2 seconds depending on how your cluster is configured. It can do that. Microsoft started with 2 node clusters, but right now today Microsoft clustering support up to 16 nodes in a cluster. So you can have up to 16 servers in a cluster like this, and they will all be not load balance clustered like this. They will all have a shared hard drives and things like that. When it comes here, there's a problem in this clustering. The storage which is presented to all these servers are kind of a single point failure. If this storage fails, everything is gone down. But that is where you have the latest EMC or NetApp storage arrays like VMAX and VNX and all, which are highly redundant storage arrays and things like that. So this is a Microsoft clustering service, and it has nothing to do with what we're going to learn today. But I just wanted to put that what is Microsoft clustering. Microsoft also has something called a software-based load balancing technique, which is normally called as a NLB. It is called as a network load balancing. Network load balancing is a software from Microsoft which will allow you to load balance. So for example, your company bankofamerica.com is having web servers. If your website is running from Bank of America, BOFA, is running from this web server, it works fine. But if this server goes down, bankofamerica.com website will be down. That time, Microsoft came up with this technique called as NLB, which is a software-based technique where all these servers are connected to one single IP address like 10.10.10.50, which is again we call it as a VIP or a virtual IP address. Now all these servers are running BOF bankofamerica.com, and these servers will be in a 3-tier application. Normally these servers will be talking to some maybe sometimes to multiple application servers or database servers and things like that. So this will be a database server, which in turn is basically a 2-node Microsoft cluster. You're getting? So this is completely redundant thing. So the database is again this will be a Microsoft cluster service, active passive node, but all these web servers that are facing the external world are in a load balanced way using a software load balancer called NLB. So when somebody type www.bankofamerica.com, the IP address, in their DNS server, the IP address 10.10.50 is www.bankofamerica.com. So if anybody types bankofamerica.com, the request will come to the VIP, that means to the NLB. Then in the NLB will decide, oh, okay, first connection, okay, Kashif is coming, let me send him to this server. Then after some time, Yogendra is coming, it will say, okay, you go here. Then another guy coming, you say, go here, and it can do different ways. So there are different ways you can configure how the traffic will go between the servers, so that, your load will be kind of equally shared between these servers, so that you get a better performance. You won't have any data congestion or anything like that. And also the advantage is if one of the server you want to take it down or goes down, bankofamerica.com will continue to work because it has 3 other servers serving the same website. Only issue is the people who might have connected to that server might experience some problem. Otherwise, it will be pretty clean. So that is NLB, Microsoft thing. This is a software-based load balancer. But in the industry, if you look at it in today's world, there is a lot of enterprise-wide load balancers are there. And one of the thing is actually called Big IP F5 load balancers, which are very famous. I think pretty much if you look at any company, you will be using these things. These are F5 load balancers. These are hardware devices that can do the same job as an NLB software. These are complex devices, costly devices. There are different models. LTMs are there, something called as local traffic control. You can see that different models are there and things like that. And here is a good example of how a load balancing actually happening. You can see that, the big IP from the internet, the connection will come to the F5 load balancer, and then it will be serving across multiple servers. So that is exactly what a load balancer really do. If you look at this picture, you can see again the same thing. These are the 3 servers, but the load is balancing through a load balancer. So if you look at, so your load balancer can be used in different environments. I'm just trying to see. So here is actually a good picture of how an F5 load balancer will look like. You can see all the ports. You can connect all this stuff there. It's actually from a company called Big IP. Okay. Big IP is the company that actually do load balancing. I'm just trying to see here, this is a good picture how the load balancing really works. So you can see that there are 2 load balancers they put, because if one load balancer goes down, your entire site is down. So you don't want that. So normally when they deploy 2 load balancers. So if one of them goes down, other one will take care of it. Now these load balancers do some kind of a heartbeat. Heartbeat means they always check these servers and make sure that they are always up and running. So in big IP F5 load balancers, there is something called as I rules. I used to work on F5 quite a lot around 4 or 5 years back. It's something called as I rules. I rules are set of rules you can customize, you can write. It is some small programs you can write, and you can specify, okay, when there is the 1020 connection comes up, send this across all the servers, or you can do, round robin. You can do, first in, first out. The first connection will go to here, second connection go here. Or you can say, do a round robin. First connection goes to the first server, second connection goes to the second server. You can also say that, there is something called as sticky sessions. There is a term called sticky sessions. Sticky session means, I have 2 servers that are running bankofamerica.com using an F5 load balancer. The F5 load balancer is balancing. So both sites are running yahoo.com. But when a user, let's say bankofamerica.com, so somebody, Kashif, is logging to bankofamerica.com, it comes to F5. F5 say, okay, Kashif, you go to the first server. Now from that server, Kashif is starting his account transaction or something. Every time, when you normally do a browser transaction, client server transaction, it is not just one connection. There is a lot of connections going back and forth between the server and your browser in order to establish that connection, and that connection is called as a session. So a session is not just one connection, it is a set of connections that is going between, when you log into Bank of America and do all your transactions and you log out, that entire thing is called as a session. So during that session, I could say, by using something called as sticky connections, I can say, okay, always make sure that all the connection from Kashif will go to this server. Don't do the first connection here and second connection here. That will create problems. So you can do so many ways. You can customize the way the traffic goes between these servers. So Cisco CSS is another company. Big IP F5 is another company. Citrix has a product called NetScaler, where I would say very famous NetScalers. NetScalers are also very powerful load balancing thing that is getting a lot of traction in the industry now. A lot of companies are using NetScalers. They are pretty much a big competitor for F5. So when it comes to Amazon provides similar type of load balancing. That load balancer is called as Elastic Load Balancer. So here it is. Elastic Load Balancing automatically distributes incoming application traffic across multiple Amazon instances. So when you have the traffic comes in, ELB knows how to do that, and it will split the traffic between multiple servers, or depends on what you're saying, it can be done that. So it enables you to achieve a fault tolerance in your application, seamlessly providing required amount of load balancing. So it's good so that, if you have two servers, one server will not be getting 90% traffic. You can pretty much load balance it so that it will be like 50-50 traffic. Now the beauty of that is if one server goes down, your website will continue to work. Now, in a normal scenario, you need only two servers, but in a big environment, when you have too much traffic, you may have a 10 to 15 to 100 to 200 servers may be part of an ELB load balancer. They are called as instance. There is something called as pool members. Any servers that you're adding to an ELB is called as a pool member. So you can add many servers into that pool, and they will all get load balancers. So Amazon recently added a newer load balancer also. There are two types of load balancers now. Pretty much they both are same, I would say, but certain newer functionalities that Amazon is now started offering for something like, Docker containers or EC2 containers and all, yes, little, the way they operate is little different. So because of that, they came up with a new load balancer recently. So there are two load balancers. One is called as a classic load balancer, and another one is called as an application load balancer. We will do one of them. Basically classic load balancer is what everybody uses. Application load balancer is more for Dockers and stuff like that. So if you look at a load balancer, classic or application, they both pretty much same. Okay, they both do the exact same thing, but I will try to explain this. But looks like, you guys, many of you don't have any idea about load balancers, so I don't think it makes really sense for me to really getting deeper into that. It doesn't make any sense, but giving you a good understanding of what a load balancer and how it operates is what I'm going to focus today. So classic load balancer, high availability, which we already discussed. It can distribute the incoming traffic and among multiple servers. It can do health checks. Health check is like if you have 3 servers in a pool, and if all the 3 servers are serving bankofamerica.com, a load balancer can check whether any server is having any problem. We deployed a web server the other day, and we created a website, correct? So if that website is not responding, if this IIS server, the Microsoft Internet Information Server, is stopped, or the WW service is not running, that website is not, the server may be up, but the website is not coming. So you can configure these load balancers to really check the status of that website, and if that server is not serving a page, the load balancer can immediately mark it as down, so that no traffic will go to that server. It will make sure that all the traffic will go to healthy host. So EC2 classic load balancers can detect health of Amazon EC2 instances. So when it detects unhealthy Amazon instances, it no longer routes traffic to those instances and spread the load across the remaining healthy hosts. And it is very clearly, clean English that is written there, so you understand what that means is. Security features, load balancers can also have security groups. You can attach security groups to the load balancers. so that you can control who can access it, who can come through that. All those things can be done. SSL offloading, everybody know what SSL is. Everybody know what a certificate is for SSL. So if your company is having a website and that website is SSL protected, that means your company will have a VeriSign or some kind of a certificate. You have it, and that certificate needs to be terminated. When you SSL certificate actually encrypts your data, but when the request comes to the server, it has to be decrypted, or in normal way, in technical terms, we always use the word offloading. So SSL offloading, that means you can configure your elastic load balancers with the SSL certificates, and then you can actually terminate those certificates at the SSL level. So here, classic load balancers supports SSL termination, including offloading of SSL decryption. So that means you can configure your ELB, the elastic load balancers, with certificates or SSL certificates, so that all the websites that these ELB supports can be encrypted. Also mentioned about sticky sessions. Sticky sessions are sessions, once Kashif start browsing bankofamerica.com, and if he is being directed to server number 3, entire session he will be staying in that. So when I say that session, I just wanted to explain to you. So let's say this is Kashif's web computer, and this is a web browser, a website where bankofamerica.com is running using an F5 load balancer or an ELB load balancer. So what happens is, when Kashif come and type bankofamerica.com in his browser, he open his site and typed browser and type www.bankofamerica.com. The request will come here. The F5 will say, okay, you go to this server. When it comes to this server, this is connection number 1. So he established the session here. Then this server will say, okay, you come here. Here is the login page. So now Kashif will get the username and password field. That is the request number 2. Now Kashif is going to enter the username and password. That will come back to F5, and F5 will again direct it to here. That is session number 3. Now the username and password came here. Now this server will take that username and password. It will go to the database server and get it verified. And from the database server, it will get verified and authenticated, and it says, oh, okay, you are good. And at that point, the server will give back him his account page. Now in the account page, if he wants to go to his checking account or saving accounts, or he wants to go to his credit card, he might click on his checking account there. Now it will create another session. It will come back here. So you see that, all these things is called as a session. So you see that in a session, how many times a computer goes. When I was working in Merrill Lynch, I used to work on their external web servers. This is how you need to really troubleshoot. A lot of people say, I just type bankofamerica.com. I got the username and password thing. No, but before getting that, you see that the computer has done so many connections. But it is very important that in this type of a scenario, for a transaction web page, it has to make sure that the connection will always come to the same server. If you do the 2 things here and then the F5 will send your connection to here, then it is a problem. But if it is a static website, just like Hello World, or just a static website, like my Solvency's website where my training materials are published, it doesn't matter if the first request come here and second request goes to here, because both sites can serve the same page. Are you guys getting? So making sure a connection always comes to the same server where it is serving, that technique is called sticky session. Now there is a lot more things with this. Unless otherwise you are a load balancer expert, I don't think you really need to worry too much about it. Sticky sessions, cookie persistent, there are so many ways you can support these things. Okay. It supports IPv6, layer 4 to layer 7 load balancing. You all know what is the 7 layers. So layer 4 and layer 7, application level load balancing. Layer 4 is more of TCP IP based load balancing. So it can do based on both the things. So you can configure your server to support, HTTP or HTTPS, which is basically application level load balancing. Or you can even use just TCP ping or something to make sure. We will see what is the difference here. So basically classic load balancer support layer 4 and layer 7 load balancing. It do some monitoring, it can do some logging, all kind of things it can do. Now coming to an application level load balancer, it is same stuff, but it is little application load balance is load balancing for the same thing, nothing different here, but it has certain new features like, containerized application. This is where the Docker containers and all. So when you have Docker containers and all, I don't know how many of you know Dockers. Even I don't know much about Dockers, but Dockers are small containers that you can run. Multiple containers can be run on one server. That means one server will be serving multiple applications. Each server application will have its own port number, its own configurations. So a application level load balancer is probably a better bet or a better choice to load balance those type of applications. Abhishek, can you please mute? Okay, I'll mute it. So containerized based applications, HTTP/2 support. It's a new version of hypertext transfer protocol that uses single multiplex connection, allowing multiple requests to send on the same connection. Multiple requests can be sent using the same connection. It's a newer technology, HTTP/2. Everybody know what HTTP is, but HTTP2 is something little more advanced, latest thing, type of a protocol. So it supports WebSocket supports. WebSocket supports are again real-time messages and things like that you can do with WebSocket. Native IT support, sticky sessions support, same thing. Health checks, same thing. High availability, same thing. Security features, same thing. But look at here one thing. Instead of layer 4 and layer 7 application level load balancers only support layer 7 load balancing. That means you can only use HTTP or HTTPS based load balancing. If you're trying to ping or if you're trying to do a TCP IP based load balancing, this will not support. So pretty much all these things, it has another protection called a delete protection. Delete protection is, when you have an instance, you can put an option called termination protection, right? If you put that termination protection, you cannot terminate that instance until you go and disable that, isn't it? Just like that, a delete protection enables delete protection on an application to prevent it from accidentally deleting. So if you enable that delete protection to a load balancer, then accidental deletion of that load balancer will not happen. When you try to delete it, it will give you a warning, hey, it is protected. Do you really want to delete it? If you really want to delete it, go and disable that and then you delete it. You getting what I'm saying? And that's the same thing. If you have an instance that is the termination protection is turned on, you cannot terminate that instance until you go and disable that termination protection. So this is an additional advantage that I see on application load balancer. So this is what it is, and there is also another thing called a WAF is there. WAF is called as a WAF, or it is called as a Web Application Firewall. So that is again more firewall kind of protection for applications. You can do that. That feature is also available on application level load balancers. So here, if you look at a couple of things here, I don't need to go here anything much here to talk. We will get on to that. You can see the pricing. There is a slight difference on the pricing for both these classic and other load balancers. The load balancer, pretty much, you just create a load balancer. There is a small cost, 0.025 per elastic load balancer. If your ELB is running, there is a small cost for it, but the majority of the cost for ELB comes on the data that it is processing. How much data, how many web pages it served, how many requests it was, how many connections it had, all that is what actually contribute to the cost of a load balancer. But even if you're not doing anything, if you have a load balancer, you will have a small cost associated with it on an hourly basis. Okay. Same way, if you look at the pricing for application level load balancer, it also has the same pricing, but there is a little difference here. It is called as a it is actually this particular thing is called as a load balancer. What is that? It's called, I forgot. It's called LCU. LCU stands for what is that? Actually, I forgot. LCU stands for load balancer. There is somewhere here. LCU. Load balancer capacity unit. So they in application load balancer, they measure the in a classic load balancer, they just charge you for the basic load balancer uptime, and then for the data that is processed, how much data that is processing, it's a flat fee. Whereas when it comes to an application load balancer, the pricing is the flat fee for the load balancer, that is same, but then there is an LCU, load balancer capacity unit. So load balancer capacity unit is actually the combination of these three things: how many new connections, how many active connections, and how much bandwidth you use. Each of these things together contributes an LCU. So an LCU contains, I know, up to 25 new connections per second. If you have up to 25 new connections, it will consider as one LCU. 3,000 active connections per minute. If you have 3,000 active connections or up to 2.2 Mbps, they are charged with an LCU content. So one LCU means these many things. Then only you will have. So if you have 25 connections per second, up to 3,000 active connections per minute, and up to 2.2 Mbps of data you are transferring, it will be considered as one LCU. That means it is 0.008 per LCU for an hour. You getting? So it's a little complicated on this calculation and all. There is actually some explanations that they have given how that price is calculated. So they are giving, let us assume an application receives one new connection per second for so many minutes, and this much data is transferred for so many things in the US East region, how much it will cost. And they did all these calculations, and they're saying on a monthly basis it will come around $22. Okay, so they are seeing new connections, how much it will come, active connections, how much it will come, and then they are putting all that small values together with the uptime of 24 hours into 30 days. You can see that 24 hours into 30 days with the 0.86, that is actually the value for LCU, and they are calculating that, and they're saying it is coming around $23. Okay, so that doesn't matter. I'm just telling these are the things. So you go to the Elastic Load Balancer page, home page, and try to read it. There is an FAQ tab for both of them that says, you know, what it is. Everything that you have answers are pretty much clearly answered here. You know, what protocols it supports, what ports it can support, and all the things are clearly mentioned here. I'm not going to go through all that. These are very clearly explained here in the FAQ, what all these load balances can support. And I would strongly recommend you guys to read these FAQs, because for a certification perspective, I'm sure you will be getting some calls here, some questions from here. Okay. So this is what actually load balancer means. I hope you guys got an idea at least what a load balancer is. Now let us go and deploy a real load balancer in our environment. So a load balancer. So what I'm going to do now is basically, I have two external facing web servers. We're going to configure these web servers with the website, and then we are going to really do the load balancing, and I wanted to show you how you really do a load balancing. So in order to do that, I have to configure web servers. How many of you are familiar with the Windows servers here? So let us go and connect to these servers now. Does anybody know the password for it? I think we use Windows instance, so we don't know the password. We didn't change the password for this, isn't it? Did we? Anyway, I don't know. So let's connect, get the password, choose the file, desktop. I'll select our key pair, decrypt password. So this is the password for the first server. So I'm connecting to that first server. Here it is. And the password, I'm going to log into the first server. Okay, it's not allowing me to log in. Now, did we change the password, guys?
Hi, welcome 22. 22. Welcome 22.
Yep, that worked. Alright, so this is the first web server. I am now going to teach how to configure web servers on a Windows server, but if you guys can catch up with me, you catch it up. So Windows servers has a web server. It is called as IIS, Internet Information Server. Internet Information Server is actually a role in Windows Server. There are something called as roles and features. So you can go here and say add roles and features. So I'm actually going to deploy a Windows role called IIS here on this server. So that service is actually called as an Internet Web Server. I'm installing the IIS web server on this server. It will install .NET Framework, automatically installs .NET Framework, but there are so many other things that can go with IIS. IIS, Internet Information Server itself is a book, itself is an exam for Microsoft. If you are a Microsoft MCSE person, you know IIS itself is a exam, just like Exchange Server or something like that. So I'm actually installing a Microsoft web server on this server, and it is getting installed. So let this get installed. I'm just keeping this in the side here, and let us go and connect to our second web server, because we're going to do these two servers as load balancer, and I will show you how the traffic goes, and I wanted to show you how you can really configure a load balancer. Okay. And we will use Amazon's Elastic Load Balancer to do this. So this is the second server. So here, since I think we know the password, I think I'll be able to connect to it. Okay, so this is external web server 2, the other one is external web server 1. So in this server also I'm going to install IIS. Microsoft Windows Server can be configured as many things, that is called roles and features. You can make a server as a domain controller, as a file server, as an FTP server, as IIS server, as many things. So if you look here, you can see that a Windows server can be configured as all these things. You know, it can be Active Directory server, Federation server, DHCP server, DNS server, fax server, Hyper-V, remote access, remote desktop services, web server, deployment services. These are all different capabilities of. You can put all these things in one server, but I don't think anybody do that. But understand a Windows server is very capable. These are all the different roles and features that you can do. But what we are going to do is we're going to make this Windows server just as a web server at this point. Nobody puts all these things into one, but you can if you want to. So I'm actually installing, so these are all other role services, additional web page configurations and all, and we are installing the service here. So here that server, let it get installed. The first server, the installation is completed. So once you install the IIS server, if you go, you can see an Internet Information Server website. it comes up here. This is the Internet Information Server, web server will look like. This is your web server. There will be a default website here. IIS server is not only just a web server, it is also an application server. That is where you have these application pools and things like that. I'm not going to get into that. You can create complex DLLs and register that as application pools and stuff like this. Is the default website. Every Amazon, so every Windows server will have a default website, and you can actually browse it, so you will actually get the normal default web page. So if you see here, you can see that the default web page is coming up. This is the default web page of a Microsoft Windows server with IIS. This is how it looks like. You can create multiple websites. You can create ad website, or you can change this website. A lot of things you can do. So this server is good. So what I am going to do is, I actually wanted to put a website here. So let's go and create a website here. So normally these websites are put it in a folder called inetpub :inetpub www-root. This is where that file, the file that you saw earlier, this file is actually this file, iis.start.exe. So we don't want that. I wanted to create my own website. So I'm going to put a website here, just like what we did. So I don't know where it is, that file. Yesterday we created a file, right? Okay, my website.html here. So I'm just, this file is here, okay? There's my website.html. That file is here. Let me show you. I'm just making a small change to that file here. I'm going to say here, hello world. This is external web server 001 from AWS class 10. So this is how our website is going to look like. I'm going to save that file. So I have a website here. So that file, if I open it, you will see this is how you're going to see hello world. This is external web server 001. So that's good. So what I'm going to do is I am actually going to put that file into our server 001. This is server 002. Where is 001? I believe this is 001, correct? This is 001. Is it the name is correct? I'm not sure the name of the server. Let me see here. Okay, external web server 001. Okay, so I want to put that file into this server. So I'm going to the www root folder, and I'm actually going copying that file. I'm putting that file into this server. Now this is not going to work now. If I browse the website, it is not going to come. So I'm going to configure my IIS server to make that work. I put it on the root folder. So there is a default document, there is a page. So I actually wanted to add a page, and it is called as that site is called, that file is called mywebsite.html. And I make that as the default website. See here now, I just made that. You know, there are so many things, but I made my page as the default page. So if you go here, that is called the default document. Anytime you browse this website, that default page is the first one going to come up. So let's see whether that page is coming up now. So now the local host is showing this page, correct? Great. So this is good. So we created the first website. So I'll just close that and minimize this. So I wanted to edit this file again, and I'm going to call it as external web server 002, and I'm going to save that file. And this time I want to put this file onto the second server, which is now this is server 1, and this is server 2. So I wanted to put that file into server 2. Are you guys following me? Or everybody is just, I hope everybody is getting it, right? So
Yes.
npub www.root, I am going to copy this file and I'm putting it here. Did that, and now I need to go to the IIS server here. I'll go to the default website and I'll go to the documents. I will add the page. Same thing here. Save it and close it. And now if I browse this website, what will I see here? I'll see www2, correct? It will say web server 2. So we created 2 web servers. I'm just showing in a very, very high level. I mean, not high level. This is how it is. You know, it is not the job of you guys to create a website. If you're a guy, you can create it, but I'm just showing a website and I'm actually showing it. Any questions so far? We just created 2 web servers, and if you hit it, you know the public IP address. So I know you guys can actually test it. You know, why don't you just test this? You know, can you go to this in your browser? Can you put this IP address? What I'm doing, the public DNS IP address. Can you guys put it here? I'm just putting it here. Okay, take copy and paste that on your browser. You will see that website coming up. Are you guys seeing this website on your computers, please? Yes or no? Tell me fast. That is server 2. And
Yes.
for server 1, try this URL. For server 1, try that URL. That should come up as server 1. So when you put it here, it will come as server 1. Are you guys getting the website externally? Because these are 2 of our external facing web servers, correct? But these are 2
Yes.
separate servers, but that is not what we want. We wanted to put a load balancer behind it. That means we're going to have an external server 001 and external server 002. We're going to put these guys behind an ELB, and ELB will have an IP address. It will get a public IP address, something like whatever IP address or a URL. It will get a URL here, and when you type that URL, where will the traffic go? It will go to 01 or 02? Hmm?
Both.
Both. It will only go to one.
Depend.
Yeah, it depends on how you configure your load balancers. Typically, it will go to one of the server, and then the next request will go here if you do a round robin connection. There are different ways you can do it. If you use sticky connection, it will stay here. So this is exactly what we are going to do with an ELB. Right now, you are hitting the server straight. That is, you know, normal way of doing, but that is not. When you have a website or something you want to have high availability, this is what exactly we're going to do. Okay. And that is the next step. Is we will be learning auto scaling and things like that later, but today we are focusing on this thing. So we have 2 web servers ready, and now we're going to create a load balancer. Okay. So before doing the load balancer, I wanted to, yesterday what did we learn? I forgot. Why did we created this? Huh?
S3. We learned S3 yesterday.
Yeah, we learned S3 yesterday. Why did we created this third? I don't know. Why did we created this IP address? Okay, that's fine. Anyway, we have a public IP address. I need a public IP address. Okay, I think for something we did. Okay, I think we did this for some purpose. Okay, anyway, we have this IP address here. We can use that. So we need a public IP address because for the VIP, virtual IP, for the ELB, you need an IP address. Sometimes we'll see whether you need or not. We're going to see that. So here is the load balancers. When you click on load balancer, and you say create, there is no load balancers at this point for me, so I'm going to create a load balancer. And you have two types of load balancers which we talked about, application level load balancer and classic load balancer. We will be using a classic load balancer, that is the normal that supports TCP and HTTPS. The both things are same. The only difference is this will support more of application level. If you have containers and Docker containers and all, you can use that. Now, one thing I wanted to ask you is, we have two web servers. Are they on the same availability zone, or they are on the two different availability zones?
You're on two. Different.
No, two different availability.
A and C.
Okay,
A
so
and C.
let's go and look at our document. So we have this picture, right? We created, right?
Different.
So this is the web server, this is the web server. The two red ones are the web servers, correct? External web servers. So now what we are doing right now is, we're going to put an ELB, and ELB actually has a symbol like this or something like that. And this is going to load balance these two guys. The beauty is, the ELB is connected to outside world. If one server goes down, your website will still run, correct? Because it will go the traffic. If both of them goes down, it's a problem. If you put both the web servers here, and if you do a load balancer here, what happens if one server goes down? Site will work. But what happens if the entire availability zone goes down? The entire site will go down. Even though you have ELB, there is no use. That is why you should always put your web servers in two availability zones, two separate data centers, and you're going to load balance them using ELB. So we have two instances, two web servers, both belongs to two different availability zones, and we are going to use an ELB to load balance them. Okay. ELB is specific to VPC. Yes, absolutely. Yes, it is specific to VPC. It cannot cross a VPC. So there are two types of ELBs, internal facing and external facing, and that I will talk in a minute. Yes, ELB is within, you are creating an ELB within any availability zone. That is why you can apply security groups and things like that. So we're going to create a classic load balancer right now. You click next. You give it a name. So let us call it as, class 10 ELB. So it is asking which VPC, and this is exactly what Muthu asked me. Hey, where do you create which VPC you want to create? So we want to create it in class 10 VPC. And here is a question here, very, very important point. Create an internal load balancer or external load balancer. Internal load balancer and external load balancer, the only difference is, if you're creating an external load balancer that can support the traffic from outside world, that means that VIP, the virtual IP for that load balancer, will be a public IP address. If you're doing an internal load balancer, it will be having internal IP address. So what we are going to create is an external load balancer, because our web servers are facing outside world, and I want you guys to test it. Because of that, I'm using an external web server load balancer, so I don't need to check this. Okay. So here is the thing, what port number you want to tap. These are called listeners. Listener is where the application is spinning. So my server is running website now. It is running a web server, so it is actually port number 80 is open, and it is doing. So this is the load balancer protocol, it can do that. So you can also do TCP IP protocol, or you can do a ping or whatever, you can actually do that. So I don't need to do that. I just need to do this HTTP port number. That is it. Now you need to select the subnets. Which are the subnets where these servers are? Now that is a problem. So I need to know the subnets, but we know the subnets. Good. Because we named it correctly. See here, I don't have to. So what are the subnets these two servers belongs to? The public subnet 1 and the public subnet 2, correct? So these are the two subnets, 1A and 1C are the availability zones. These are the two subnets, 10.0.1.24 and 10.2. These are the two subnets that we need. And then you need to create a security group for your thing, security groups is the firewall. So you can create a new security group, or you can actually use your external facing web server security group itself, because external facing web server, we already allowed port number thing. But normally I don't do this. I will probably create a separate thing. You can call it as, class 10 ELB dash security group. I can do that. I'm going to say HTTP traffic 80, allowing from anywhere. I can also probably do a ICMP ping for that. No, I don't need that. Actually, that is enough. One protocol is, I'm just, this is a web server. I don't want anybody to connect. I only want HTTP traffic to come to that server now. Okay. So we'll just put that there. Configure security group. So here they are giving a warning. It is saying, hey, your load balancer security. Now I told you your load balancer can be configured as a SSL offloading capability. So they are saying, hey, you don't have HTTPS. Why don't you do that? Put your website HTTPS and all. They're saying, I don't have a certificate here, so I'm not doing it. But otherwise, you could use HTTPS. Here is the main important thing. This is where you are doing the health check. You want the ELB to check and make sure that your website is running. So you basically have to configure a page here, and I'm actually going to say that, this is my website name. I need to put a file. You can put any file there. Normally people put something called as, healthcheck.html or something like that. So our web servers have a file. What was the file, other file which was there? IIS start.html, right? This file was there. Remember, everybody remember that file? So what is going to, you guys remember what I'm saying? Let me explain this. Hold on. So this is that file. We have it, c:9netpub www root. There is a file called IIS start.exe. So IIS start.html, actually, that file, IIS start.html, okay? So what I'm going to do is, in the load balancer, I'm going to say, hey, you know what? Check for that file, IIS start.html. So what an ELB do is, ELB is going to use HTTP traffic at port 80 and see whether it can access this file. If it can access that file, what is that means? What is that means? That this is called a health check. That means the web server is running, correct? Isn't it? If it is not, then the ELB is going to mark that node down. So I'm just putting that file. Now there are some advanced time, response time. If it is not responding, this site is not responding in 5 seconds, 30 seconds interval to, and you can configure it, how many time it should wait and things like that. So I'm going to say, I just wanted to put some small numbers here. I'm going to say response timeout 2 seconds, interval is like, 5 seconds, and unhealthy threshold if 2 times, healthy threshold, again I'm saying 2 seconds. So what this means is, you will understand this. So what it says is, it will wait for 2 seconds to respond. If it does not respond for 2 seconds, after 5 seconds it will again try. If it's not accessing, it will mark as 1 unhealthy threshold. It will say 1. Then again it will do the same thing for 1 more time, and if 2 times it does not get a response from it, that means a total of 10 seconds. Even 10 seconds, if this site does not respond, what is going to do is the ELB is going to mark that server down. So this is what we are telling. So you should have a health page. This is called as a health check page. So as I said, the advantage of a classic ELB is it can support application level monitoring. That means it can do layer 7 protocol, or it can also do TCP IP base. So if you do TCP, you can just say, hey, ping that port TCP, you can do that. But a better way to do is actually check a file. Just a server may be responding to port 80, but that doesn't mean that the the website is running. So here I am doing is I'm actually checking a file inside my website and checking that that page is accessible. That is what exactly I want, right? My server may have many web servers, but I wanted to make sure that my particular website itself is running. So I'm checking a file inside my web server. Are you guys following me? So here it is done. And now you need to add your instances that you want into your thing. So these are the two servers that we wanted to add into this. Cross-zone, load balancing, is distribute traffic evenly across backend instances and all availability zone. So that's all by default, cross-zone load balancing. That is exactly we are doing. It is going to do the load balance, distributes the traffic between both of them. And also connection draining. If a connection number of seconds to existing traffic to continue, if you stop the ELB or something, it will in 300 seconds it will drain all the connection. It will slowly bring all the connections to the other server. So these are two other settings. Add a tag here. Let's call it as a name. Let's call it as class 10 ELB. Review and create. That's it. So basically this is it. So we are creating define a load balancer. We are doing all these things. This is the health check page. These are the two servers. This is the VPC. This is the subnets. This is the security group that is attached to it. Any questions on any of these things before I create? So once I create, it is going to create a load balancer. Now you may be wondering, what the heck is this load balancer? What is it creating? Are we going to see something? Actually speaking, when I create this ELB, what Amazon is doing is in the back end of their thing, you will not see that they are creating two load balancing servers, virtual appliances in the back end to do that, and it will be depending on your traffic. It may be a T2 nano or T2 micro instance, but if your traffic is going up, they will automatically make this server a bigger instance type. So basically at the back end, you won't see these instances. You will not see these instances in the instances section. But actually speaking, when I am creating a load balancer, what actually Amazon is doing is, Amazon is creating two load balancer appliances at their backend, and this appliance is actually doing your load balance. Okay, it is, even though you think it is a service, but Amazon is really doing that. So I'm going to click create, and you can see that your load balancer is created. And now if you go here, you will see that your load balancer is now available. So here it is. One more time, let's go back here. You click on the load balancer. You will see your class 10 ELB. And this is the fully qualified name of your load balancer. If you look at the name of the ELB, the DNS name, this is the A record, this is the actual URL. You don't see any IP address or anything. You don't need any IP. This is a public facing URL. You will be able to access it. You can see that it is called as internet facing, the subnets and all those things. So all you need to do is, if you take this and go to your browser and put that there, do you think we're going to see a website or not? My God, where did it go? Why is it doing that? HTTP : // that's not good. Okay, it is. What is it saying here? 0 of 2 instances in service. So we have the 2 instances added. It will take some time. Okay, it is saying these 2 instances are now out of service. So they are not. ELB thinks that they are down for some reason. I don't know. We need to find out. You can remove it from the load balancer. You can see the availability zones there. Everything is looking, no availability zone contains healthy instances. So it says the instances are down. I am not really sure why it is doing that. We'll find out. I think they are not able to hit that web page. That is the reason I think is the problem. So what I want to troubleshoot here is, I want to go to our instance. So this is our website. Remember, guys, This is one of our instance, right? Slash IIS, what was that name? IIS test, what is that? Test.html.
Start. IIS start.
What is that?
IIS start. .html.
Okay, so that is the problem. I think it is not picking up correctly that website. That's fine. So what I'm going to do is I'm not going to spend time to troubleshoot it. You know, this is something you can work with your web server. So what I want to do is, one thing I know from here sure is that my load balancer is up and running. Everything looks good to me. I don't see any problems. But it is saying that both the instances, external web server 1 and 2, load balancer is thinking that they are down. They are out of service. So the problem is mostly with this health check, it is not able to check that IIS restart page. So I'm going to edit that and I'm going to make it into a TCP port 80. So that way I know it will ping, it can ping that server on that, which is going to do a TCP ping to that port 80, and I'm going to save it. So I just changed the health check properties. So let's see now what happens. So now you see it came back. Now the server say, ELB say, hey, I can ping that port 80. But the website, you know, that page I gave was a problem. But I told you, right, I'm not going to troubleshoot. You guys understand what I'm doing, right? I was not able to hit that page. ELB was not able to hit that page. That could be some website configuration problem. I don't want to troubleshoot that. We could fix that problem, but I'm not going to do. But right now I changed the health check straight to do a ping to port 80. You know, telnet to port 80. Hey, check that. And it is saying the health service is good. So now that is good. Let us, I put that in the chat window. Can everybody go there and see what website are you seeing? Are you seeing any website? You are not putting any service address. You are putting the ELB's URL here. I am hitting 001 and look at now. I'm going to refresh this. I'm going to refresh this page every 2 minutes. Okay, now look at this. Okay, here you do this. See, now I am on hitting 2. So keep on refreshing your page. You will see that you are going 01, 02. Which server you are hitting? When you get 02, which server are you hitting?
I'm hitting 01 now.
Yeah, keep refreshing. You will see that it is doing a round robin. Isn't it?
Yeah, it couldn't. It's changing.
So even if one server is down,
I don't see what you are saying.
what is that?
I see 001.
What is that?
No, you are saying web server 002, right? I'm seeing 001.
No, you refresh it. You refresh your page. See, I'm doing it here. See, on my page,
Yeah.
I'm refreshing. You will see it is switching between 001 and 002. Are you guys, everybody testing or not?
Yes, it's working for me.
Okay. It should work for everybody because I'm working. It is a public thing, you know, Jacob. Okay, good. So this is what is happening. So now now can you say it's load balancer? So now what happens? Look at it. You know what I'm going to do is I am going to one of the server and I'm going to stop this website. I'm going to the website and I'm going to stop this website. Or let's say the server is down. Is it my website is going to go down?
No.
Okay, check it out. So which server are you all hitting now?
2.
Everybody will be hitting 2 now, isn't it?
Yes.
Right.
Is the same URL?
That is the beauty of ELB, right? The same URL, you will be balancing 2 servers, but one server is down, but your website is still working. Is this highly available? Is it load
Yes.
balancing? So when 2 servers are there, the traffic is going between 2 of them.
How many server we can connect to a load balancer?
I don't know the maximum number. How many? I think you can add as many as you want. I think, you know, maybe you can, and I don't know, you're going to put I'm sure you're not going to put 100 servers there, but you can put quite
I mean,
some.
we can put more than 2, right?
Oh, you can absolutely, yes. You can absolutely add more and more. See, all these servers can be added here. You can add all that servers and add it to the instances. So you can see that, and then whatever is down, it will say out of service. Only one server is in service right now. If you don't want them, you can remove them from the load balancer. So these are the two servers out of service. External web server 001 is showing as out of service, and you see what happens now. As soon as I start the website on that 001, the website is stopped. I'm going to start this now, and you can see that the load balancer will now mark it as up. It will take a few minutes for it to come up. It is in service. So now you go to the website again and just search and try. You will be seeing your round robin between both the things.
Yep, it's working.
Okay, so that is ELB. Test it out. Very, very important topic, and ELB is a very, very powerful and very useful feature in Amazon. Every company has to use it. That is the only way you can provide high availability. Maybe a very important topic, I would say, very, very important topic. From an exam perspective also, they might ask a lot of questions from here. Not a lot of questions, you're definitely going to get one or two questions, and this can be easily answered. So try it out, health check page, listeners, this is the listener port, this is the port that we are listening. It also has a monitoring. You can see that the traffic and all that things it will do. All that things, you can actually configure it, monitoring everything. You can do that here. This is what is a load balancer. Now you can create application based load balancer or classic. They both are pretty the same thing. Here, they are showing a different picture. They are putting two servers in one availability zones, two servers in availability zones. They are configuring them as something called as target group. You can put these servers in one target group and these two servers in target group, and then you can say that, on a normal day, let all my traffic goes to these two servers only. If these two are down, then go to here. You can do like that. So these are some of the advantages of this. And also with the application load balancer, you have some additional capabilities like, as I said, delete on protection. Now this load balancer, the problem is, if you go to this load balancer, you can actually delete that load balancer. See here, load balancer. You can come here and you can actually action and you can delete that load balancer. There is no warnings or anything. You click delete, you will delete it. But if you do an application load balancer, you can have a protection for it and some differences. So I would definitely recommend all of you to definitely read about this AWS ELB. Go to this home page of ELB and try to understand this thing. I would say read these FAQs. That will give you pretty much answers for all the things. If you really want to know the difference between a classic load balancer and application load balancer, it is right here. Supported protocols. Classic supports all these protocols, whereas application supports all these protocols. HTTP2 and WebSockets are supported there. Supported classic to supports EC2 classic, the old technology, and also the VPC. This one only supports VPC. Sticky sessions, both of them supports. Backend authentication, this is support. Backend authentication is where, if you have other servers to do an authentication, it can do that. This won't do. Idle connection timeout. If a connection is idle for a certain time, they will have connection draining, it is supported in both. Cross-zone load balancing. Cross-zone load balancing is what we did. We have two servers in two availability zones and we are load balancing them between the availability zones. It is supported here. In application, it is always enabled. Here you can disable that if you want to. Health checks. Health check. This is one major difference I would say in application load balancer is way capable more. Health checks. What we did here, we only have TCP ping or health check page. Those are the two settings that we can do for checking the health of the system. But in application load balancer, it has enhanced capabilities. When you configure it, you can find out that there may be some additional options you may get for checking health. And not only the port, you can also check sometimes something else on a server, or you can check another file on a server to conclude, okay, I will check this and that to determine whether the server is down. Okay, if this is working and this is not working, I can still serve the page, so you can do that. So Ravi Teja is asking a question, what are tags in ELB? So what is tag, Ravi? Can you speak? Ravi Teja, can you please speak for me?
Yeah.
Okay, what is a tag?
Tag is something like you give a name, right?
Huh?
You give something like a name.
Okay. So that is the tag. Tag everywhere is tagging is same. So what are tags in ELB is, you can give the name of your ELB, you can tag it, whatever name. So I gave the name, thing. So you want to add another tag called department. You can call it as IT and save it. So next time when you search here for ELB, when you have too many ELBs, you just type IT, it will show up, the IT thing will come up. You have to filter it.
And department might be.
Yeah, I think you need to, no, not like that actually. Hold on, there is only one instance. I think that's why it's not showing. But you can actually use your tag here. It should be IT. I mean, when you do IT, there is only one. That's why it is showing. If you have two ELBs, you will see that. Okay. So tag is just a normal tag.
Deepu, we have seen one architecture when we were searching, right? So that they're using two ELBs. So now if I create another ELB, and can I attach the same instances to the other ELB as well?
You can, but that is not the picture that I showed is, let me take that here. So the architecture picture I showed you here is, you're talking about this picture, correct? This is the ELB. This ELB is doing these two things. Do you all understand this? This is our external facing web servers. Two web servers here, two web servers here. You're load balancing them. Is this clear for everybody? This is exactly this is exactly what we did now, right?
Yeah. But I'm not talking about this. When we were searching about the F5, we have seen a picture in Google like they've used two ELBs. One ELB fails. The other one was used.
Okay, yeah, that's correct. So that is for high availability, right? That is for high availability.
High availability.
That is for F5 because F5 is a physical device, right? If that physical device fails, you don't need to do it. But I told you when Amazon creates an ELB in the back end, they are providing actually two instances to do that ELB for you. So there is actually two of them they are creating. So you don't need to worry about it. In ELB, you don't have to do two ELBs to support one website. No, you don't have to. It is a highly redundant, highly available service. Amazon is guaranteeing that an ELB will not go down. Now, ELB can go down, but 99.999% time an ELB is a highly available service, and Amazon is taking care of that availability. It's not our headache. So they are providing the load balancer. But when it is a real physical world, when you have two F5 load balancer, you should definitely put two because these are hardware. It can go down, correct?
Yeah.
So these ELBs are these part of a particular availability zone? These servers are physically located in one particular availability zone?
It is not an available zone. It is actually in VPC. So it is coming as a service. So you don't need to really worry about it, or we don't need to worry about whether it is in an availability, not in an availability zone. It is in that region they are providing, but it can support multiple availability zones.
Okay, so basically if an availability zone goes down, it would still be working, can route the traffic to the other server, right?
Absolutely, yes.
Okay, thanks.
Now, a more complex design, I just wanted to put it for your thought process. I'm not going to explain, or we're not going to do that. So I have in Virginia, I have a VPC, and in Oregon, I have a VPC. and I have a load balancer here, ELB, and I have a ELB here. This ELB is supporting 2 servers running bankofamerica.com. This is also running 2 web servers running bankofamerica.com. The purpose of doing this is, if entire Virginia goes down, I want to get bankofamerica.com coming from Oregon. This is in Oregon and this is in Virginia. Will that work? These are 2 separate ELBs. So ELBs, you cannot do that for geographical transfer. So that is where, when we will be learning that later, whereas Amazon has something called as a Route 53, which is a DNS based load balancer. So basically you can configure this ELB to this Route 53 and this ELB to this Route 53. So the Route 53 will be checking the health of these 2 ELBs. If both the instances in this ELB is down, this ELB will be marked as down. So the Route 53 know that, oh, okay, you know what, everybody is coming. So people are coming. bankofamerica.com website, the VIP is actually here. The real VIP to the outside world is here. So when bankofamerica.com come here, Route 53 will say, okay, you guys go here. It will be mostly, the rule will be always send traffic to here, and this is always 0. That means always send traffic to Virginia. But if both the Virginias are down and the ELB in Virginia is down, then Route 53 will send the traffic to here. So now you have a regional protection, correct? Are you guys following what I'm saying? So this is a little one more level up. Okay, I'm talking about a geographical load balancing, but an ELB, you cannot put an ELB to do 2 regions load balance. An ELB is only available within a region. So if you want to do a geographical based load balancing, then you need to take advantage of Amazon's feature called Route 53, which is Amazon's DNS server, which can actually do this load balancing. And we will probably talk about this when we learn Route 53. Okay, so Route 53 is very powerful, and that's how you really do that. And you know, many companies do that. So geographical load balancing is done using that. All right. I think we'll stop here, guys. You know, I don't have time to start. I actually thought I could able to do auto scaling today, but I think it is going to take some time. I actually have to do some work, personal work I need to do. So I think we will stop here today, but I hope you all understand ELB. It is very interesting topic. It can be easily done. And now you can use Windows servers or Linux servers or any Amazon EC2 instance type can be used for load balancing, whether it is Ubuntu or whether it is Red Hat or whether it is Windows Server. You can configure it to use load balancer. Now load balancers are not used just for web servers. It can be also used for application load balancing. It can be used for database failovers. It can be used for many different purposes. What we did, or what I demonstrated today, is a load balancing a simple website. But as your requirements becomes complex, don't worry, the load balancer ELB is very powerful and it can do that. Now, if you don't want ELB and you want more and more features of your F5 and things like that, then you can deploy F5 load balancers here. And I think I did show you that you can go to load balancer, you go to marketplace and you can download F5 appliances here and configure them as instead of ELB. So if you have an F5 appliances and you're ready to pay $13,000 every year, you could use F5 to load balance those 2 instances. Same thing can be done using F5. The advantage is probably, you know, F5 has maybe a little bit more features and things like that if your company is really wanted to do it. But 90% companies are not using this type of load balancer. There is really no need to do that. But you know, it all depends on each company's requirement. Even though in my business company, we have F5s, a lot of F5 load balancers in our internal office. But in Amazon, we are not using F5. We are still using ELB and it works fine. No issues at all. It works extremely good. How to assign real website address to a load balancer? That is a question. Can anybody answer that? So this is our ELB URL. But you don't want this. You wanted, instead of this, you wanted to see, www.mutthusubramani.com. Correct, Muthu? That is what you want, right? When you type mutthusubramani.com, you want to see this website. How do we do that? Anybody?
In Route 53, we need to create a host zone, and there, if we give our domain name, which if we have something like from GoDaddy or something, then we need to give the.
That's correct. So basically, you create a CNAME record in your DNS. So basically, you go to your DNS server. Now, it can be Route 53, it can be GoDaddy, it can be Network Solution, wherever you want to register your domain name. Muthu is going to register a domain name called mutthusubramani.com, and you go there and you tell them, hey, you know what, this is a CNAME record, so you need to create a CNAME record to it. When we learn as our Route 53, we will learn a little bit more on that, but basically you just tell them that, my website is this record. Now, you cannot get an IP address to this, okay? There is an IP address to this. If you ping this URL, probably you might get an IP address right now. You might get an IP address when you ping this. Let me see if you will get it or not. Sometimes Amazon disable that, but if you do that, you might probably get a response. Okay, see here, they're not doing that. Okay, so there is an IP address here. You can see that 52.72.123.252. That is the address, IP address of that. Now, you cannot use that IP address, or you should not, I would rather say, you should not be using that IP address to map www.mutthusubramani.com. Why? I'm telling you, that is the IP address of that URL. So if you go to Network Solutions and say, okay, mutthusubramani.com equal to this IP address, and I'm saying it should not be used. Why?
Maybe because it's one of the server's IP address.
It is not the one of the server's IP address. It is the VIP of your F5.
Oh, it is a VIP. It is a VIP.
It is a VIP of your F5. It is not supposed to change in real world, but in the case of an ELB, Amazon is not guaranteeing that IP address, because when your traffic goes up, so what happens is, I told you, an ELB is nothing but two small instances running in the backend. Okay, these are two small instances running in the backend with a VIP IP address called this IP address. But when your traffic website is becoming more and more and more busy, what Amazon do is they basically take one of this node down, and then they upgrade this to a larger instance, and then they down this and then take a larger instance. At that time, this IP address can change. If the IP address changes, does mutthusubramani.com will work? So that is why you should never register your website or your domain name with this ELB IP address. Rather, you should use this. Okay. Guys, I don't want to tell the number. There are more than 20 people in this class. Can I see a yes or no or okay from you guys, whether you understand this topic?
Yes.
Let me see how many type yes here. How many of you sleeping are there? Let me see. Okay, I see some new names coming up. Okay. Okay, so I think that's good. Everybody is saying yes. So it is clear, right? Everybody understand that. So that's good. So this is a very important topic. You got to understand, read it, and try it and practice it. Okay, it will be really useful. All right. So now tomorrow.
Another quick question. So the Route 53, it's applicable only if we have load balancer in two VPCs, right? If you're going to be in one, all the instances going to be one VPC, do we need to go to Route 53?
No, you don't have to. You need to use Route 53 to do a load balancing. Route 53 is not a load balancer. It is a DNS server. It can do many things. You can even register your domain muthusubramani.com on Route 53. It is they are also a name registrar. Amazon is a name registrar, just like GoDaddy.com, just like the networksolution.com. Amazon is today a network registrar. So you can actually register your new domain name or buy your domain names from Amazon, and that will be configured in Route 53. Route 53 can also act as a DNS server, and that is the Route 53 that is giving all these DNS names to your internal instances and external instances, everything. But Route 53 can also be used for geographical load balancing. If your requirement is you want to load balance between two regions, you have to use it. If your instances are all within one region, then one region means within a VPC, then you don't have to. If it is between two VPCs, then it's a whole different ballgame. I mean, you can still do it using VPC peering and things like that, and you know what is VPC peering and all, right? So you can do VPC peering and do that. But if this Route 53 will come into picture only if you are planning to do load balancing between two VPCs across two different regions. Okay. All right, so that's the plan, guys. So tomorrow, actually speaking, I definitely have a lot of things to do. Actually, I have some very important personal commitments to do. So if I cancel tomorrow's class, then we'll not have class for 3 days. Okay. That means Thursday, Friday. Actually, the plan was there was no class today and tomorrow, but that got cancelled. But I have so many other things. So tomorrow's class at this point I will say 50-50 chance. But if the class is not there, I will definitely let you guys know before 9 o'clock. Okay, at least by 8:30. I know it will be a little difficult for you guys whether or not. If it is not there, I could have gone, you know. But let me see. If possible, I will at least let you know by 4-5 o'clock if there is no class. Okay. Otherwise, we will have class. I actually wanted, we have still a lot of topics to cover. You know, I wanted to finish off this at least by 15th of February. I don't want to drag it too much. We have so many topics to cover, and every day, you know, it is taking time. It is not easy, you know. Believe me, nobody spent this much time. So today, you know, we spend that much time for it. But I hope you guys, I mean, I'm glad that you all understand this. But we still need to do a lot of things. We need to talk a little bit about EFS. I want to talk a little bit about storage gateway. I'm not going to do anything, but at least I wanted to talk and make you understand what is EFS, what is storage gateway. We need to do RDS, very, very important topic. We need to get into IAM. We need to get onto all these things. We need to get onto device farm. We need to talk about SNS. We need to talk about Route 53. Yeah, I think that is it pretty much I'll be talking about. And then server migration I might touch.
Before I have a question. Is it like that Route 53 is a temporary one, or is it like a permanent one? Like once I take the leave, once I register there, it's done.
I cannot hear you, Ravi. Can you be a little more loud?
Is it like that Route 53 registration, right? Of the domain name, is it like a permanent one or like is it a temporary lease kind of a thing?
No, 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 no. No, no, no. Route 53 is here. Look at this. Read that. Okay. So it can do DNS management, it can do traffic management, it can do check availability checks, it can do name registration. So it is permanent. If you want to raviteja.com, you want to register it, it is just like GoDaddy. They are a registrar. Amazon is now a name registrar. You know. So you can do here registered domains. So you can go here. You want to register a name. Let's Ravi Teja, right? raviteja.com, $12. Let's see whether we'll get it or not.
So already registered.
No, that is not there. Okay. Maybe you may have it or somebody else. There are 2 Ravi Tejas in this class. Is that correct?
Is it?
That is what I heard. This Ravi Teja is R Teja. Where is why? There is another guy. You know, Srikant. You know him. Where is the other Ravi Teja? Okay, I need to figure out that problem actually. I was little. So who is Yaramati? Ravi Teja Yaramati. That's not you, right? Okay. So there is a Ravi Teja Yaramati there from your company. Anyway, never mind. All right, so thanks guys and good night. We will continue. I did see some payments from you guys, you know, those who have not made payments, you know, please look into this, okay? Those who have not paid, yeah, Coyote, Elton, you know, I don't know the name, but I will get back to you guys on that tomorrow. Please make sure you make the payment before Monday, okay? I'll give you time till Monday, but Monday, please make sure. I don't want to go behind everybody. Yeah, Kashif is saying shut down the instances. Yes, I will. So I'm actually going to basically delete that ELB also, okay? Because that is going to cost me some money.
Very quick question. So I'm setting up this 3-tier environment. When I try to connect from the web server to app server, it is timing out. So I'm still working on it. Do you know anything on top of your mind? What could be the issue? Because those the web server is on the one subnet, and the app server is on the another subnet, and the database on the another subnet. So I'm trying to connect from the web server to app server.
Are you able to ping? Are you able to ping from web server to the app server?
Yeah, I'm able to ping. Yes, I'm able to ping. I'm able to RDP also.
Okay.
Only thing is when it connect through the connector, the Tomcat connector, it is timing out. So I'm working on it.
So what is the port number you're trying to connect? Is that port is open on the security group?
Yeah, it is 80, port number 80. It is open.
What connector you are trying to connect?
I'm trying to connect through the AJP connector, AJP 1.3. It's IIS Tomcat connector.
Okay, so as long as the ports are open, then I don't know. It should be your application problem. I don't know what to do on that.
Okay.
If you
Yeah,
can
probably
ping, if you can ping, if you can RDP, you know, and your port, what you wanted to, your application to talk is open, then it should work. But that means it looks like it is an application problem. Maybe your connector is not working properly or some configuration issues. It is nothing to do with VPC or subnet or anything because the connection is flowing back and forth. But I would definitely double check on your
security group.
security
Okay.
group, and also if it is Windows servers, so you may want, or Linux servers, you may want to check the operating system level firewall. There may be a firewall within the operating system that is blocking maybe.
Okay, I'll check that. Yeah.
All right. Okay then, guys. Thank you and good night. Tomorrow's class, mostly at this point, my mind is saying, we'll take a break. So if there is no class tomorrow, then we'll not have class for 3 days. Okay. So Thursday, no, tomorrow is Thursday, right? Thursday, Friday, Saturday, Sunday will be the class. But next week we'll have class. I'll try to do every day. So let me see how many days we more have. So if tomorrow I miss, then we'll have class on Sunday. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hopefully by 16th I will be able to finish. That is what I'm looking for. Okay. Definitely don't want to extend it. If I couldn't finish it, we'll do a Saturday or something, a little long hour and finish it off. But I think I'll be able to finish. But the problem is each of the topics that we want to talk might take an hour, so I might go a little faster, but these are all topics that I need to talk. So many things to cover. That's fine. We'll do it. If we need a couple more days, we'll do it. So thank you and good night, guys.
Thank you.
All right, good night.